Strong Hand, or rather Build Pro table, that's the trade name that we use for it, is a modular fixturing solution. Traditionally, when you go into manufacturers, what you'll find is they use jigs when they have to produce the same part over and over and over again. But what happens if the parts that you're having to produce constantly change? Well, it's very expensive to make a jig for each one of those particular products. And that's why somebody came up with the idea of modular fixturing. So the way that these tables are designed is it's a series of holes, and different kinds of tooling can be used to go in those holes to hold pieces in place and try to minimize the fit-up time that's required when fabricating any part or piece of equipment. To give a brief overview of the table, the table itself is made of steel. This black finish that you see on the table is actually a chemical process that's done at the end of the manufacturing of the table. It's called plasma nitration. And what that does is it creates a very contamination resistant surface. It also makes it so that spatter doesn't want to stick to it as much. You can scrape the spatter off much more easily, especially when you're MIG welding. And it also makes it incredibly hard. The tables that we have here, they come in all different sizes. The BotX often will come on a table that's 4x4. We make up to a 10x5, and the tables can actually be connected together in such a way that the table flatness remains very consistent even when they're joined together. So we can usually come up with a solution for just about any application that gives you the table size and form factor that's required to fabricate the part that you're looking to fabricate. The holes in the table are 5/8 inch, and that's also the exact same thickness that the table is. So many of the places that I go to, I see people struggling with just trying to get a 90-degree angle. Let's just say that you're building a frame for something and you need to create a 90-degree angle. Well, one thing that you know is that these holes on the table are precision 2 inches, 2-inch centers, and you know that they're straight. So we have some very simple pieces of tooling that can be used. This is an example. They're called stops. So if I'm to put a piece here and I'm to put a piece here, I know when I bump that piece of material up against those two stops, I'm completely square. Now, let's say that I had another piece that I had to bring in to weld to it, and I knew that that had to be done at a perfect 90-degree angle. I could very simply do something similar. I could take two of those stops and I could put them on the other side. This is also one of the other very common pieces of tooling that's used. These, and you have a static hole here and an adjustable piece here. And that's if, let's just say that you know you need a 90-degree, but you don't know exactly where it's going to have to go. This is where the ball lock joints come in, because the ball locks are what allow you to join tooling like this to the table. And boom, tightens down. But one of the ways that I like to do this for purposes of using this as quickly as possible is to get this in place where it's snug with whatever you're trying to clamp down, then release, give about another half a turn, and clamp. And you should have enough pressure to hold this tight into place. There's another piece of tooling that we use that's quite common. that instead of being this insert plier is a T-post. Now the T-post can be used to do some of the same types of fixturing, hold some of the same types of pieces of material down, except as you can see, it has a bigger profile. And so these are advantageous to use whenever possible because they keep a lower profile and they stay out of the way of one, just being able to work around, and two, the robot itself being able to move around and perform its work. These can also be used on pipe. The T-post clamps are incredibly versatile. I think the only problem with these as they relate to the BotX system especially is they do create an obstacle. The system can be designed to go around obstacles, so not so much a problem, but you know, when we're trying to do things as quickly and efficiently as possible, I think that using something like this is still preferable to using something like this if you can manage to do so. Then following that, I would say these T-post clamps that you see here being used to hold this piece of tubing. You can see there's V-grooves machined into there for being able to hold tubular products. It can be turned like this, it can be tightened. This piece can be taken off and is magnetic. Underneath the pipe, you have this puck that's designed for holding just that. Very wide, very large diameter, very small diameter piping or tubing. And just to give an example of how I might combine a few of these things together to make something that's workable, get up off of the table. So that's an example of how, if I had to extend, let's just say that I had to take this round tubing and get it farther away from the table, I could do it. One other thing that we have that's very interesting is this, which is actually adjustable. Let's just say that you were just about a ½ inch off. Well, this, you could put this here, and then this can actually be adjusted, can rise up and down as needed.